Hello everybody and welcome back. I've got a new video here and I'm just going to talk about sea levels, present some data, a few pictures, and then you can make up your mind what you think is going to happen. But I just thought it'd be nice to throw some of this stuff out there because there's so much confusion. People don't know what's going on with all this climate change and global warming, global cooling, so there's a lot of confusion going on. So I just thought I'd straighten a few things out here and just kind of get it into one video here for people that want to know what's going on with sea level. So I've got a whole bunch of pictures here, and then I'm going to go through the time scale, show historical sea levels back to about 540 million years, which is all they really have records for. Past that, the continents didn't even look anything like what they look like now. So I'll just throw out a few facts, here and there. Here we have the Antarctic and the Arctic. And this is during winter time in the southern hemisphere on the right, and on the left is summer in the northern hemisphere. I'm going to show a video of this showing that as this one increases, this one decreases, and they go back, and it just oscillates back and forth. So we're theoretically should have the same amount of ice here as there, and there shouldn't be any net gain or loss in sea level, except for a few little problems. So if all that ice was to melt, including the ice on Greenland, which there's an awful lot more ice there than looks, this is what you'd have. 250-meter rise is about 820 feet, I think. Two and a half billion to maybe 1 billion years ago, the planet did go through a really cold stage where it was almost all ice and sea levels were as low as they can be. This is a theory, it's called the snow globe theory. This is Sacramento Valley here, California. This is San Francisco. So yeah, the worst that could happen is what you see here. Quickly, your Greenland without the ice, but no isostatic rebound or sea level rise. So it would become an island, a very small. All the stuff in the red and brown here would be above water. Here we have the nighttime view, which is really kind of a good picture because it shows really almost how much heat is coming off the planet. Every single one of those light bulbs, every gallon of gas of the trillions of gallons of gas being burned in the sky and on the ground, campfires, forest fires, you name it, it's all adding heat. Carbon dioxide is not the whole picture, and people that go around saying, well, carbon dioxide's causing, we got to cut down on the carbon dioxide. Well, you can cut down on the carbon dioxide. I'm not sure it's going to make any difference because you're not going to stop the heat. There is too much heat, period. And ever since humans got on this planet, they've been making heat. And the equation is very simple. You add heat, the ice melts, the sea level goes up. Yes, gases can cause that, but the problem is it gets hot before the CO2 naturally goes up, which is fine. But we're adding an awful lot of carbon dioxide, carbon monoxide, nitrous oxides, and a lot of other stuff, hydrofluorocarbons, to the atmosphere. So we're adding all this in on top. And that may be our undoing right there, but then we have the heat problem. 1 gallon of gas creates about 3,000 cubic feet of hot air. The air went in cold, it came out hot. So if we're going to burn trillions of tons of fossil fuels that all give out, that all create a lot of heat, the planet's going to heat up just because of that. And so it's just because of the fact that civilization is even there that we're getting heat. So that's the situation right there in a nutshell. I probably don't even have to go over the graphs, but let's go over them anyway. I'll show you some facts and figures and graphs. Here's the rundown on the fuel. Most of everything is done by weight. So, you know, this is important when it comes to your chemical stoichiometry. You're going to need this stuff. A lot of fake stuff out there. This is trying to say that the heat comes in, goes through the layer of carbon dioxide, through it, doesn't bounce off, goes right through it, hits the surface, heats the surface up, then goes up, then it hits this layer of carbon dioxide and bounces back. Well, that's not really possible, because if this kept happening, no heat would escape and the planet would burn up in a week. This isn't light, because light's not going to do that, come up and bounce back, because light itself is not heat. There's a big misconception, and they play upon this for, you know, propaganda purposes, saying that, oh, well, if we cut the light off, we'll cut the heat. Well, that's true if you cut the light off completely, but the problem is the heat. You can't see. It goes right through anything. And if you put a layer up here of anything, it's just going to heat that layer off. Some of it's going to be bounced off, but just as much is going to be bounced in as bounced off. So it basically heats this area up here and continues on to heat the planet. Then the heat rises, and if there's no cloud cover, it goes right out into outer space. But if you have cloud cover, as in weather engineering, aerosol spraying of the atmosphere and so on, that heat's going to go, where's it going to go? It's going to stay. It's not going to go out into outer space. So by fogging up the planet like this atmosphere, really you're keeping the heat in. Okay? And that's the bottom line. This picture's a complete lie. So look out what you see out there. It's a lot of it's just, you know, they'll tell a lie just to convince you of something. This is the Milankovitch graphs of precession and obliquity, eccentricity, solar forcing, and then here are our glacier ice ages down here. And notice pretty regular. Down here on the left lower, this is now, and note how the glacier, the ice age came to an end, and then the temperature rose quickly. This is probably a temperature gauge, but it doesn't matter. The temperature, CO2, sea level, all of those graphs look almost identical. And notice how quickly it goes up and smoothly with no spikes. And it happens every time. It goes down. It takes a long time to get down there. And then boom, it shoots up really quick, very quickly. So we've already gone through that stage. 20,000 years ago, sea level, you know, was low as the temperature was low because there was more ice. So it started warming up, the ice melted, and it got to the top over here, and then it started to go down, but then now it's going up, and we've got spikes. So it's starting to look like this over here, where it goes up, and then you have spikes where it goes up and down, but ultimately it ends up down here. Another thing to note too is that these temperatures only go so cold, that's it. It never goes to minus 1,000 degrees or anything. It always comes down only to a certain temperature, and then it starts to come up, and then it only comes up to a certain temperature. So it stays within this range because of all of this going on up here. Every time these phenomenons here line up just right, it affects the temperature of the planet. So sea level, same kind of curves, quick heating of or melting of the ice, rising of the sea level. Takes a long time to go down, have like many ice ages in here or whatever. Gets down to the bottom, cold as it can be, then it warms up fairly quickly. So that's an interesting thing to notice. CO2 levels, almost the same graphs. Here's present over here on the right this time, but you see how it just slowly follows the temperature and the sea level, and then boom, shoots out. And then up at the top here we have sea level. But a general sea level change here right in the middle, it's going up. So it's not going down, it's going up. Here we have the carbon dioxide ice core record. This is the famous Vostok one done by the Russians. And it shows a normal pattern here, except that for the end, this isn't up to the recent time. We're actually up way over 300. We're almost 400 now, which is the highest that it's ever been. It's never been that high. So, yeah, we're adding carbon dioxide. There is absolutely no doubt about it. You can read this. That it explains down here in the bottom about how the CO2 increase lags behind the temperature increase. So therefore the CO2 does not cause the temperature to go up. It was already going up, and then the CO2 kicks in because of the oceans getting warmer, more calcium carbonates giving out carbon dioxide, and so on. Over here, actually, I was going to delete this one because it's too confusing, but you can take a look at it anyway there. You have to pause your device and just take a look because, I got lots of these to go here. So here's another one. This basically, they're telling a little bit about how they come to the conclusions that the sea level was where it is, and they're basically using oxygen 18 isotope ratios found in forams. And different parts of the world too, and then they compare the data and come up with something. This tells us the sea level rise right now is at 1.5 centimeters per year. Ideally, it shouldn't be going up or down in our lifetimes. We should not be noticing things like this. Here we go, another very up-to-date graph here by NOAA, and you can see the increase of the sea level here, but then it kind of stopped and leveled off, but it's going to probably go up. Well, it's got to go up or down. We don't really know. This shows a fairly sharp increase here, but if you stretch this over out millions of years, which we're going to do, you'll see that the overall trend was going down, even though it went up after a ice age. You have to take the average. Global cooling, I don't know why they're calling it cooling, because this shows it warming. Over here, we're only talking 1/4 of a degree, but we have a lot of spikes. Don't know why. This is too short a period for the Milankovitch effect to have any bearing on this. And then this is just a little history on the ice ages that we've had lately. You can also pause, look at that. Sorry, I'm trying to go fast because I don't want this video to be 10 hours long. Just more graphs. The key point here is on the right side. These are 3 different studies, and they compared their data, and these are the 3 graphs they came up with. Okay, so that's present on the right. They all have the same pattern at the top. This one at the bottom is very common. It comes up and just, you can see it's starting to level off. Why? Because it got to the top of the peak. It peaked out. These temperatures never go over a certain point, and they never go below. So that's good. It's kept within that frame of temperature there. I don't know if it's possible that you could have everything just stay a straight line all the way across all the time. There's just too many things going on, and other than human intervention. Another one, carbon dioxide, the dust. They use the dust to determine also glaciation and stuff. Then up here we have the temperature versus the carbon dioxide. Notice the graphs are the same. Notice the tops. Notice the carbon went up, and then, but now it's going up again. See, it's like we were up. The melting, happens fast, so it happened fast over here, but this one has a spike on it. We're up here. Actually, we're way up here on the carbon dioxide. That must be a picture, and it's too bad because the picture, these graphs are just a couple of years old, and we see that they're so different. Just over a couple of years. I don't really think we should be seeing these kind of increases in anything here. Fossil fuel burning down here. That's just nice. Carbon dioxide, methane, nitrous oxide again. That's even been looked at. These are data points. They don't really have, a lot of these don't connect. Same thing here. Methane going up. Carbon dioxide up. This is what Earth looked like about 2 billion years or so. It went through a really bad cold stage. As soon as the atmosphere kicked in and oxygenation started and so on, we had it was possible to start snowing. This is important. Again, straight from NASA. And I don't think they're just doing this as propaganda. Here's the Arctic, and it shows a decline of about what looks like 2 million square kilometers of ice. We lost that off the Arctic. Then the Antarctic, though, has gained, but not much. It hasn't gained enough to offset that loss. And these are square miles of sea ice, okay? This is not necessarily the thickness of the ice and stuff, so these could be skewed off a little bit. And then down here we have the combined, which you can see there's still a net loss here, but at least, I don't know, 1.5 million square kilometers. So there's the data. It's right there. More, all showing the same thing. This is how the ice melts in, say, this is Greenland. It starts off from satellite, looks pretty good. It looks like the edges are still here. And it hasn't actually melted back, but it has, because this is almost all solid water in here because it's melting. And it's, going farther and farther out. It stays here because, this is a big sheet of the water just kind of running across the top. And it starts melting back further and further. And if you look at these here, this looks the same here, but there's more water coming out of these on the bottom than the top, because that's how much it's draining. So that, even though it doesn't look like it's losing ice, it's losing water. Nitrous oxide up. Well, I'll bring this. You can look at this. Another oxygen 18 isotope data here. 300 meters is 984 foot rise if it were to go that high. That's the absolute maximum, though. All ice in the whole planet melts. You could get this. Flood map. With 250 meter rise. So that's about the extent of it. There is land left. I mean, you can still go, but look at Europe. I mean, they're gone. Australia. Brazil will never be the same. North America. This is my favorite. San Francisco Bay Area. Sacramento Valley. I live over here. I think I'm going to move over here somewhere. Maybe. But then, you know, in my lifetime, it's not going to come up enough. Unless something goes ballistic and we have runaway heat. Which is possible. I mean, the sun could do something to us. Here's 3 different versions of sea level rise. Depends on who you believe. Muller, Hayek, Miller. Carbon dioxide versus temperature. You know, right in step with each other. More graphs. Present level. This is kind of a sea level thing. This is really basic graphs. I might just take this one out. I don't like it. Temperatures. Hold that, take a look. Not a whole lot to see there. Oh, here are 3 gases. They're all going up. Notice the dates down here. 1750, so this is, you know, 1750. So there's a couple 100 years right in here, and we're definitely showing something here. This is when they're on this scale. Man was not here. Or humans, I should say, we're not here at this low point here. So we did not cause that to go up. That went up. It was going to go up all on its own. Supposed to be seeing more and more of this, but you got to be pretty stupid to build a house, you know, or even live there. I don't care how poor you are. It's time to get out. So, on the geologic time scale, and I'm sorry I can't make this thing bigger, or if I did, you wouldn't be able to see it, so I had to zoom in. It's such a huge chart. This is my favorite one. Here's the time scale there, pretty nice one. It shows the continents where they were at that particular time. The part that I'm going to be looking at here is right here. You'll see, and unfortunately I have no pointer when I'm in this PDF document, but to the far right of the scale right here where it says sea level, that's 300, and I think it goes down to minus 100 here, and I think the very bottom would be about minus 140 meters. And this is the sea level. The black and white stripes are polar reversals, magnetic reversals. And so if we just go back, if I can adjust this and get the bottom up there, that'd be nice. There we go. It starts off here at 540 million years ago, pretty low. It's less than what it is now, and this is recovering, I think. See how it's gradually, the sea level is just very gradually going up. I think it was still recovering from the snow globe period, when everything that was frozen that could be frozen was frozen. And I don't know how far down the sea level could actually go if it just kept staying, it just stayed cold and just forever and ever. How low would that sea level go? That's an awful lot of water to pile up. It seemed to me that the ocean would just have to freeze. But anyway, following the scale up here, we could follow it through the hundreds of millions of years here. It had a really high part there. There doesn't seem to be any correlation with the magnetic reversals here. It ends up going down again, very low. And when we switch over here, I can't even see that pointer. I tried this on my Linux machine, but it couldn't take the graphics. It was very disappointing. So we're extremely low here, 250 million years. Look how low. And then it just gradually goes up, 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 up. And those Milankovitch cycles are all, you know, they're probably these little dents you see here, but those would be, if you magnify this line here on the blue area, it would be extremely rough with all kinds of jagged ups and downs and ups and downs, and you'd probably start to see a pattern there of ups and downs with the general trend of going up and down. Okay, so we're following this up here, and we're at the top, and that's now. And it was going down. It was very gradually going down over a period of millions of years, of course, and that's slow. But I mean, that is so slow that even a centimeter a year, this would be astronomical. A centimeter a year, this scale on the right would just be dropping or going up very steeply if it continued like that. So once you get on the geologic time scale here and see that this stuff takes millions of years, and we're having an effect on it in a very short time, and we should not even be seeing anything in our lifetimes of 100 years. We should not see anything to speak of. This one here is interesting. This is a temperature graph here on the orange and blue, the orange being hotter. But this only goes back 5 million years, I think. 5 million years. So, well, it's a few million, but it's not 100 million, but it's coming from the warm area there, and it just goes right on up, and it's getting cooler, but it's getting more erratic. So, that could be scary, that it's so erratic. It's taking these erratic swings up and down, up and down. And what could cause that? Well, it's really started getting erratic, I don't know, a couple of million years ago, 2.5 million. That's a long time ago, but just to show you, they do have temperature readings that go back 5 million years at least. Over at the NASA SVS site, we have a nice little video here that probably you should see if you didn't know this already. I'll go ahead and run it. There we go. So as seasons changed, the one on the right would be winter in the north hemisphere, and then as summer comes, it melts and it forms here. A couple things I can say about this is that ice that's out here is sea ice. Now, if it came from water that evaporated from the ocean and then is deposited here, you have no net increase or decrease in sea level because it came from the ocean. Now it's sitting in the ocean, so it's not going to, even though it's sticking up out of the water, it's not really going to displace any more than what it took to evaporate that and put it there. But a lot of that, of course, didn't come from land. The ocean, it came from land too. So, it's pretty complicated to try to figure in all of these different factors. And over here in the North American, or the Northern Hemisphere, sorry, a lot of this snow falls on actual land. And so anything that falls on land will deplete the ocean. And when it melts off the land, that goes back into the water. When this melts here, it doesn't really raise or lower the sea level because the ice is already sitting there and it's already raised it up as much as it's going to go. So that doesn't do anything. Now you have to, think about this, that as the ice forms here, it decreases here. So it basically goes back and forth because we have a closed system here. Earth has only so much water, and this is what happens. But it goes back and forth. So you don't really, theoretically, we shouldn't really be gaining or losing sea level. And ice has actually been melting in the northern hemisphere. And we've been gaining ice in the southern hemisphere down around Antarctica. In fact, they had record ice there as far back, just 2014 was a record year. But then we've had record years for ice loss over here on the northern part. So there's a little something going on there that you never hear about on the news. So to end this video, I'm going to show you pictures of flying saucers. What else could they be? These are flying so fast that they come across this entire valley and only show up in maybe 1 or 2 frames. Actually 2, maybe 3 frames. The speed's been estimated, I think I worked it out on paper to be about 25,000 miles an hour. These things are just darting all over the place. Here is another shot of that. I should probably magnify that up a little for you here. And this particular one was flying, but coming through this valley here, came between these 2 mountains, just swooped right through and boom, swooped off to the left, back and forth a couple of times. Got a lot more pictures of this. These were taken by somebody else that happened to be and this is the desert in Southern California. There's another sort of enhanced picture. Kind of a fat little thing, isn't it? It's not really flat like you'd expect it to be. Almost looks like there's something on top of it, but it's just so hard to tell. I mean, it was going like, so fast. If you were looking, you would probably notice something going by, but you would have thought it was a bee or something just flying past, really. So here you go. Then I got it down in black and white. Looks about the same. And this is only one shot. I mean, there's like 50 shots of this thing in all different positions, all over the place, coming in, going all around. This thing was just flying all over the place. Like I said, unless you were looking for it, you wouldn't even see it. You just wouldn't see it. So anyway, thanks for stopping by. I hope you enjoyed the video. I hope this gives you some kind of insight on what is really going on with the sea level. Also, I try not to influence anybody anyway, so you look at the data yourself, but I think the bottom line here is to realize that it's the actual heat generated by human civilization, period. Yes, the gases have a lot to do with it. We can't dump trillions of tons of garbage into the air, and we can't geoengineer our atmosphere for weather or military purposes or whatever. This planet is not disposable. Don't know why they don't see that. So to me, it looked like we were going on an ice age, but why the chemtrailing? Why all this atmospheric weather modification? Just really makes you wonder, because it's in secret. We don't know why they're doing it. It looks like they're trying to heat the planet up. That's what they're doing. But then at the same time, claiming global warming, we have to pay gore, we have to pay taxes, and money is not going to fix this. The human race has gotten off to a bad start. It should never have been monetized. It should never have been based on, fossil fuel burning. I mean, how stupid. And we've got all this back-engineered technology that's been withheld because maybe they're going to release it later. Maybe it won't make enough profit right now because, after all, we are a profit-based civilization here. I'll bet these aliens that show up here, they're just probably aghast at what they see, the chaos and the you know, the pollution, and just it must be just a real sight to behold to come up on this planet and see what's that stuff in the air. Why is it so foggy? Well, oh well, you know, I guess that's the world we live in, and there's really not much we can do about it. Because if we were to be able to do something about it, nothing would be like it is now. With 7 billion people, or whatever it is, there's already too many people. Yes, there's a lot of room to spread out, but, you know, if we don't get going on this uh, clean energy, and I don't mean just a bunch of solar panels that create 50,000 tons of carbon just to build them. There's back engineered technology, or engineered or secret, using all kinds of different things, and I don't need to go into it now, but it's there, but it's not available to us. It's only available to what I would call probably the breakaway civilization that will end up on top of all of this after we are gone. And if things keep going the way we're going, and I'm not trying to be an alarmist here, I'm just putting out the facts. You saw the graphs, everything is going up. Something has to be done. But then on the other hand, I think, well, what can be done? I don't think anything can be done unless you just get rid of the human race. Oh yeah, that'll save the world. But it doesn't help us much. So, you know, we're in dire straits right now, and the next few years are going to be real interesting to see what's going on. Keep an eye on that snow melt and the sea level rise, and that should tell you all you need to know as far as, you know, if you need to be moving or anything like that. At least your ancestors may have to move anyway. So it's going to either go up, and if it goes down, that means that the planet's cooling and it's going to go right on into the ice age. That's what Earth is all about. So anyway, I hope you enjoyed the video. Thanks for stopping by. We'll see you the next time.